Hey guys. So my name is Micah Winkelspecht. I'm the CEO and founder of GEM. Adam and Shane did a really good job of introducing blockchain topics, so I kind of anticipated that. So we're going to go a little bit deeper into how we actually manage these assets once you have a blockchain. So GEM is really connecting the world with digital money. We help businesses and financial institutions rapidly build blockchain solutions to solve real problems. What our core platform really is it's a full blockchain asset management platform for the enterprise. We essentially help you issue, secure, transact, and audit digital assets on any blockchain, and the keyword is any blockchain. So our platform is blockchain agnostic, and it works with multiple types of blockchains. And in fact, we're going to go into this, but there's many different people who are building the low-level blockchain layers. And there's a lot of competition, and it's very early to tell who's going to win, which one's going to get the most consensus. And so when you're an institution, it's very hard to sort of figure that world out. Our platform basically allows you to hold assets on multiple blockchains all at the same time. So you don't have to make that choice, and in fact, we will help you make those choices. So, what is a blockchain? Since Adam really went into this pretty deeply, I'm just going to sort of brush on it. But I think my definition is a little bit different. I think that the blockchain is really the operating system for distributed applications. Whenever you take a centralized system, a central database, and you take the power of that central institution or that central counterparty, and you push that power out to the edge nodes, what you're really doing is you're disrupting that system. Distribution equals disruption. And right now, there are projects in every single one of these different verticals that are looking to use blockchain technology to essentially disseminate that power out to the edge nodes. And we're going to see a pretty dramatic revolution, not just in the finance world, but also in just general software because of this innovation. But we're going to focus today on the real money aspects of the blockchain. So where are we with adoption of this technology? I think, how many people in the room have heard about blockchains before this event? I would imagine in this room almost everybody. How many people could actually explain what the blockchain was before this event? Yeah, okay, so about half. So, we have a long road here in terms of adoption, and it's going to take a long time to replace all of these systems. It really started with the cypherpunk and libertarian movement, and then it very quickly developed to startups and developers and investors, and largely that's where we've been up to this point. But the next few years are going to be almost dominated by real use cases at large enterprises and financial institutions. This is going to be a very long process, and they're going to start by building proof of concepts and pilot projects, and ultimately those will end up scaling to full production solutions. And while a lot of companies built consumer-based solutions very early on, I think that actually is a ways out. So really the value here is going to be captured by the enterprise first. So why are they so excited? What is the net benefit to a financial institution for using a blockchain? Well, there's many, and I'm not going to cover all of them. And in fact, several banks have come out and said we found 20 to 25 use cases for our business where a blockchain could basically add a lot of value. I'm going to talk about the 5 main reasons that I think financial institutions are excited about blockchains. Custodianship. So blockchains actually redefine the way we think about ownership of assets. Instead of having a counterparty or a third party that you have to trust with your assets, the blockchain allows you to essentially hold your own assets. But there's a way to do it where you can get all the benefits of a custodian. You can get all the security of a custodian without ever turning over your control to that third party. You can actually maintain your own assets and get bank-level security. And I'm going to talk about how that works and the mechanics of it. Automated contract enforcement. This is often referred to as smart contracts. But really what this means is that things that we used to do with laws and human enforcement of rules can now be actually programmed in with code and attached directly to the money and the assets themselves. And the assets basically have to follow the code. So we can basically take the entire human element out of the enforcement of contracts. And this can be now applied to things like bonds and derivatives and futures, energy contracts. We can start to apply these rules, code-based rules, to all of the different asset classes that we have in the financial system. Instant clearing and settlement. Once you have digital assets, and those digital assets are residing on a blockchain, now you can start to do things like instant clearing and settlement. If you have digital assets and you can do an atomic swap, or like Chain was mentioning, that you can put them in the same exact transaction, you really don't have a settlement process anymore. You're doing instant settlement. And so this is a very, very exciting development, because a lot of the risk in the financial system is based on the idea that an asset is traded first and then settled later. If we can remove that time, we can go from T+3 or T+7 to T+0, we can massively reduce the risk in the entire global financial system. So this is a huge win for the banks. And another major cost to banks right now is compliance and reporting. So, since the 2009 financial crisis, compliance costs, reporting costs have gone through the roof. Well, if you have a public record or a public blockchain, or even a private blockchain where regulators have special access to be able to view that chain, then why do you need to do reporting? If you can basically give a regulator a particular key for a transaction, then they can go and look up the data themselves. They can view the data themselves. On the compliance side, in terms of KYC, there's a lot of interesting applications here too. So if we can take, say, a Bitcoin wallet or a Bitcoin node and essentially attach an identity to it, now we can basically do KYC verification one time. And if everybody's trading on that same system, that same blockchain, we do one verification. Now that trader is basically good to trade with any of the partners that are on that blockchain because they've already done the KYC verification. So there's huge, huge, massive gains that we can make from this. And then finally, the most important is interoperability. When we look back to TCP/IP on the internet, that was really a protocol that basically defined the rules for how everybody in the world was going to move data packets to each other, back and forth. There are many ways to move data packets over raw wires. It happened to be that we chose this particular standard and this particular protocol, and then the world all agreed to follow that protocol to move their data packets. And the benefits and the gains to society, because we all agreed on those rules, was extremely massive, and it allowed for the explosion of what we now have, and it's very obvious. It's a lot less obvious in the financial side, but most of the systems in the financial system, most of the software that runs in the financial system is all disparate systems, siloed, and by having interoperability across all the banks and by agreeing to a common language about how we're going to talk about financial transactions, we can essentially build the internet of value or the internet of money, and it will really transform the world from the bottom up. So, we can start to see all these benefits, and they're really massive, and they're going to take a huge shift in the way we think about and build these financial systems. And the problem is that these are also very complicated systems. So if you're going to build a blockchain solution, there's a lot of things that come with that that you have to now think about in a different way. So first of all, you have to actually pick your blockchain, right? And right now, that's a very confusing environment because there are many different competitors who are all vying to sort of build the underlying blockchain infrastructure that all the banks will use. And if that wasn't complicated enough, there's actually multiple types of blockchains. So most of us are familiar with the public type blockchain. Bitcoin is the best example of that, the most well-known. There are also, Litecoin, Ethereum, Dogecoin, BitShares. There's about 700, actually, blockchains that are currently in existence right now in the public sphere. On the other side, you have private blockchains. So these are systems that basically allow you to have a controlled set of transaction validating nodes that you can specify the IPs. You know exactly who is participating, and they have specific public keys that are allowed to basically validate those transactions. And in that sector, there's a huge number of people who are vying to build these solutions. And then the most interesting stuff is really on the federated side. I'm going to have to add Chain to this list today. So side chains, Factom, Ripple, these are basically sort of a mix between the two. And so when you're looking at these solutions, there's a lot to choose from. And you might want to be able to pick multiple solutions depending on your use case because they have different strengths and weaknesses. Now, once you've figured out what blockchain you want to use, and now you've figured out how to, say, issue assets on those blockchains, now you have to have a way to actually hold and store those assets and protect those assets. And so, with Bitcoin, the way we secure assets is we use public key, private key cryptography. And so now all of a sudden you have to be an expert in cryptography and security, and you have to be able to protect private keys. And there's a problem, and I call it the 10% problem. We're really bad at securing these private keys. So 10% of all Bitcoins that have ever existed have been lost or stolen due to poor security. 10%. To put that in perspective, that's $350 million in lost value. And we're talking about a total market cap of all Bitcoin of only $3.5 billion. What happens when we go from Bitcoin to the new financial system? We start attaching our stocks, bonds, derivatives, options, futures, energy contracts, real estate to these digital tokens. We need to solve the security problem. So this is really top of mind. Luckily, blockchains actually afford us new solutions and new ways of thinking about security that we never had with traditional money. So for instance, most transactions we think of in blockchains are based on a single key system. There's a single private key that is basically the title to that value. But we can do really complex things like adding multiple keys. So now we can secure a single asset and split it up across multiple keys. You can think of the analogy of a missile silo, where you have one guy with one key and another guy with another key, and they both have to turn the keys at the same time. We can now do the exact same thing, but with money. So for instance, every transaction that goes through the GEM platform requires at least 2 keys to sign off. And so, in the cases where we're working to secure, say, an exchange or a merchant processor, essentially our customer has one key and we have the other, and we both have to agree on those transactions in order to move that money. And then, in order to prevent us from having custody or control over your funds, we can actually issue the customer a second backup key that is a purely offline cold storage key. It's hack-proof. It never touches the internet. And this can be used for disaster recovery. So now the customer is always in possession of 2 keys. They always have enough keys to be able to move their money without us. At the same time, we're able to provide bank-level security on those funds by basically blocking transactions. So the next step is actually figuring out, that's called multi-signature wallets. So the next step is how do we block those transactions when we think they're fraudulent? So now we have to take into account, is the actor actually who they say they are, and do they have the actual authorization to move these funds? And that's where you go to sort of what we call rules enforcement. And this is common in the payment space. We're talking about spending limits, velocity controls, multifactor authentication, enterprise access management, fraud detection, whitelisting, threshold approvals. So anything over $10,000 requires both John and Sally to sign. These kinds of rules need to be added to these systems to be really robust on an enterprise scale. And our platform actually includes a full rules enforcement engine, and it's actually customizable. So you can actually script custom rules that make sense only for your business, and you can include things like third-party data sources and other types of systems that can be plugged into this model. And finally, you have to actually build out your own infrastructure. And you have to be really careful about how you build this out. You have a lot of people who are going to try to attack you for these very valuable private keys that are being used on your system. Now, we looked at what the banks were doing to secure private keys. It turns out that private keys have been used in banking for decades. So we tried to see what the banks have been doing to secure these private keys. And they use what are called hardware security modules. Hardware security module is basically a single-purpose machine that goes into your data center, and its entire purpose in life is to basically generate cryptographic private keys and use them to sign transactions, to do cryptography. And these devices are certified to certain standards, so that the devices that we use are what are called FIPS Level 3 certified. And that means that even if you had an attacker who was physically in your data center and had access directly to the machine, if they tried to pry it open, the device would actually self-destruct the data. So it's kind of like Mission Impossible kind of stuff. And so all of our keys are actually generated and stored and used inside of these devices, and they never leave those devices. So if you're trying to build a blockchain solution, you've got a lot of things to consider. You have to select your chain. You have to be able to issue assets. You have to be able to secure those assets. You have to authorize and authenticate the users of your system and make sure that they have access to perform these transactions. And you have to build out the entire infrastructure yourself. And on top of that, these technologies are very, very young. And so they're changing all the time. So now you actually have to have people who are managing the configuration and keeping up to date on changes in the protocols. This is a very, very young, growing industry. So you could do all of this yourself, or you could use the GEM platform. And so essentially, we basically wrap up all the hard parts of building blockchain solutions, and we put it all into one package, and then we wrap it behind just a few lines of code. So now you can get up and running very, very quickly. And on top of that, we've actually built client libraries and SDKs in almost every language. So now you have a really easy way to access all of this great technology from one integration point, and you can use the same integration across multiple blockchains with multiple different types of assets. And on top of that, our team is always here to basically support you from the ground up. So we work with a lot of Bitcoin ecosystem companies in the startup space, but we also are working with large financial institutions. And so what we do for them is really, we try to get involved as early as possible, and we will essentially help educate, run seminars, explain all the different opportunities, help you identify use cases in your business, and then help to plan proof of concepts and pilot projects that you can launch to essentially prove this technology out. And then we can help you actually scale that technology all the way to production. And so that's what GEM does, and I'm happy we have about 3 minutes, so I'm happy to answer any questions.
So we have a question. How do people steal Bitcoins after they're transferred? You mentioned 10%, which seems pretty high.
It is very high. There's different attack vectors. I mean, the best attack vector would be to actually get direct access to the private key itself. If you have, so this is why Bitcoin is a little bit different, or blockchains are different, in that the actual asset is the private key. So that the asset, the value is stored on the public blockchain or a federated blockchain or private blockchain. The value is stored on the blockchain, but your access to that value is actually contained within a piece of data that you hold that is unique, and that is the private key. And if you're doing it correctly, you and only you will be the only person that ever knows that little piece of data. Think about it like a very long password that nobody will ever be able to guess. But if that's sitting on a system, an insecure system, it's sitting on a web server, or it's sitting pretty much anywhere, and a hacker breaks in and is able to access that key, once they have that raw data, they don't have to actually get any more permission from you. They can actually just take that raw key and run a raw transaction on the Bitcoin network or on the blockchain network that you're working on, and they can broadcast that transaction directly without any involvement from you. So losing a private key is the #1 way that you can lose funds. But there's also other attack vectors. BitPay just recently suffered an attack where it was actually a social engineering attack, where they basically used Gmail and other methods to convince somebody to send Bitcoin transactions to the wrong person. And the problem with that is these transactions are irreversible. So if you can convince somebody to do that, there's really no recourse. Some of the federated chains and private blockchains are starting to introduce ways where if you get a consensus vote across all the transaction validating nodes, you might be able to roll back a transaction, which is a contentious issue. But there are many ways to solve these problems. What we really focus on is really a top-down approach, so people, processes, and technology.